It is the unseen guardian of every electrical system, a safety net buried beneath the earth. Earthing and grounding are the absolute foundation of electrical safety. The core challenge is the fault current, uncontrolled electricity caused by insulation, failure, or short circuits, which can electrocute people or destroy equipment. The primary goal of grounding is to provide an easy, low-resistance path for that fault current, diverting it away from humans and sensitive components. We will break down two key terms: equipment grounding for personal safety and system grounding for system stability, and how they work in harmony. The Earth is the ultimate electrical sink. By connecting our systems to it, we ensure that excess electrical potential is safely neutralized. Equipment grounding is the safety feature that protects people. It physically bonds the metal casing of every electrical device to the ground. In a fault scenario, a live wire touches the metal casing. Without grounding, the casing becomes energized, creating an electrocution hazard. With grounding, the fault current instantly sees the low-resistance path provided by the ground wire, completing a very high current circuit back to the source. This massive, intentional surge of current immediately trips the nearest circuit breaker or blows the fuse, instantly disconnecting the power to the faulty device. This rapid interruption removes the electrical potential from the casing, saving the life of any operator who might touch the equipment. The speed of the trip is crucial. The ground path must have the lowest possible resistance to ensure the fault current is high enough to trip the breaker immediately. System grounding is about stability. It involves grounding one of the current-carrying conductors, typically the neutral wire, at the source transformer. This stabilizes the system voltage. It prevents dangerous voltage swings on the live conductors, reducing stress on the insulation of the entire electrical network. The primary component is the ground electrode, copper, rod, or plate-driven, deep into the earth to ensure a reliable electrical connection. The effectiveness of the system depends entirely on the Earth's resistance. Dry, rocky soil has poor conductivity, requiring multiple rods or chemical enhancements. To ensure proper bonding, all metal parts, pipes, conduit, and structural steel are connected to the grounding electrode system. Ground fault circuit interrupters, GFCI, are specialized devices that sense a minute current difference between the live and neutral wires. If that imbalance is detected, meaning current is leaking to the ground, through a person or water, the GFCI instantly shuts off power. This protection is much faster and more sensitive than a standard breaker, specifically designed to prevent electrocution in damp or wet environments. Without a functioning grounding system, our high-power electrical infrastructure would be unusable, posing a continuous, deadly threat to life and property. The simplicity of grounding is its genius, using the massive low-potential Earth as the ultimate protective conductor. This invisible electrical safety shield is working constantly, silently diverting dangerous energy away from where we live and work. We hope this deep dive into the fundamental science of earthing and grounding has given you a newfound appreciation for safety.